Hi, my name's Ed Nolan and I am an A-level psychology teacher. In our video today, we're going to look at using inferential statistics to accept and reject our null and experimental or research hypotheses. So we're going to review some of the stuff we looked at in previous videos, and it's going to be quite a long video, and it's going to be some pretty technical, but we'll get there. You will get there. So remember our 5 steps that we used in order to take a statistical test and relate it to our hypotheses. Remember the first one, we had to look at our levels of significance, and that generally psychologists will use as a minimum a 0.05, meaning the probability that their results occurred by chance was 5% or less in order to accept the hypothesis, but could use other levels of significance. Selecting an appropriate test, which we looked at in a previous video, then being able to use the test to calculate an observed value, relate that then to a critical value, and once you've got that information, accept or reject your null hypotheses. Well, in this video, we are going to look at 3, 4, and 5. So let's go through some key terms first of all. The observed value is the value that is used or established from the statistical test. Critical value is a value that is needed to be compared to. Say, look at this point. This is a critical point where we can say whether we're going to accept or reject the hypotheses. And we get that from a critical value table, which we're going to look at today. The one that I want to dwell on is this idea of a one-tailed test. One-tailed test is another term for directional hypotheses. If you have a directional hypothesis, you're saying that condition A will be more than condition B, or there will be a significant positive or negative correlation. There is one outcome that will support your hypotheses. However, if you have a non-directional hypothesis called two-tailed, meaning that you're going to say there's a difference between condition A and B, so condition A could be higher or condition B. Or that there will be a correlation, so it could be positive or it could be negative. There are two outcomes, and so that is a two-tailed test. So what you just need to remember is one-tailed if you've got a directional hypothesis, and two-tailed if you've got a non-directional hypothesis. Let's have a look at these observed values. So you carry out an equation to calculate an observed value, and this is what the statistical test does. In our exam board, you will not have to carry out any of those equations. You just need to know what an observed value is. Okay, so it's the number that's produced. Now that observed value will be presented to you as a letter, well, a number and a letter. So it will say a letter equals and then a number. If you see that, you know it's your observed value. But of course, it's not that straightforward because different statistical tests will use different letters. So for instance, a sign test will be an S. Now, by the way, this is called a chi-squared. Chi is actually a letter in the Greek alphabet. It is nothing to do with Southeast Asia. So there's no ch-ch, it's a k. It's a chi-squared test. Okay, and that's with the chi letter, which is like a swirly X. Then a Wilcoxon is a T test, so it's a T. A Mann-Whitney U has a U value. And a Spearman Row, we'll see it in different ways. It's called a row. Sometimes you'll see it as an R or an R with a little S on it. Okay, so what you need to worry about is if you see one of those letters with an equal and a number, you know that that's the observed value. It's good to know them as well, just in case a later question says what statistical test should be used, and you're like, well, they've already said it was a T test, T number there, so we know it's a Wilcoxon. So it's another way of just safeguarding on that question. So you will see it represented like you can see down the bottom there with that R value. So there we have R equals 6.78. Now another point to look at is that if you're using a correlational study, if you're looking at a chi-squared for correlations, or we're looking for Spearman Road for a correlation, that observed value also acts as your correlation coefficient, meaning a number between -1 and +1 that says the strength and direction of your correlation. Right, so the critical value. Now, you get the critical value from a critical value table. So this is the number that you have your observed value. You have to compare it to the critical value. It's called critical because it's the point that if you get to there, that means you've got a significant finding. So that's why it's critical. Now, the way it's represented is through these kinds of tables. Now, if you look on the side there, Charles Edward Spearman, who was a psychologist. I love that because when all these geographers and biologists and chemists say, oh yeah, we've done a Spearman, I'm like, yeah, that was a psychologist, Spearman. So they use tables like this. And what you've got to be able to do is read a table like that to identify a critical value. That will happen in the exam board. Now, at the moment, you might be like this emoji, and you're like, whoa, no way. But you know what? I've been teaching psychology for 20 years now, and I've got students through this, and you can do it. You will be able to get to do it. You might need to watch this video. There's a long video again, or you might have to kind of do some reading, and you might have to have a chat to your teacher, but you will get there. Yeah? Okay, right. How do you read a critical value table? Well, there are kind of 4 things that you need to be able to have. Number 1, do you need a one-tailed or a two-tailed test? Is there one outcome or 2 outcomes that will support your hypotheses? Remember, is it directional hypotheses or non-directional? You need to know what level of significance you're going for. Mainly we look for probability of less than 5%, but it might be something else. And that generally will be said to you in the exam. You need to know your n value, not your value, your n value, which is the number of sets of data. It's generally the number of participants. Now, for one of the tests, this is seen as degrees of freedom. This is the numbers of items of data that have the ability to move or change. You don't need to worry about the technicalities of that. It will say on the exam paper the degrees of freedom are, the DF is. So you've got that. But generally, it's the numbers of items that you're measuring minus 1. And then you use all of those through columns and through rows to identify your critical value, your 4 steps. I'm going to use the 4 steps and go through each of the statistical tests on their critical value tables. So let's start with the Spearman Road. So let's say I'm doing a study and I am looking at the amount of exercise someone does and their self-report on a rating scale of their positive regard. Okay, so my hypothesis is that those who do more exercise will have higher positive regard, significant positive correlation. So I know I've got a directional hypothesis. Now, if you notice, there are different rows on the top, and there's a title row, then there's some numbers, another title row, and some other numbers. So it's kind of down there. And you will see that one of the rows relates to whether it's one-tailed or two-tailed, and the second row relates to the level of significance. So you just look for the level of significance that is related to the row above. Yeah, so I'm using a one-tailed test and I want this time 1% to chance. So that's my level of significance. Yeah, so if you got that, if I had a two-tailed test, then I would use the column to the right. Okay, so I know which column I've got. Now, I'm using correlating with 20 participants, so I know what my n value is, the number of values. I've got 20 scores that I'm going to look at, 20 pairs of scores. Okay, and so I have my row. So my critical value is 0.444. Let's have a look at the Wilcox and sign test. Now, fortunately, they have the same table to look at. As you can see, it's slightly different. So instead of rows of one-tailed, two-tailed, and the significance, they're just the columns there. Okay, so this one's a lot easier to read. So let's say I'm using a match pairs design where I'm getting participants to rate themselves on their self-regard, and then they're going to do some exercise and rate themselves. And I am saying that there will be a significant increase. So it's a one-tailed test. I'm going to use 5% to chance my level of significance, so I know my column, and I've got 20 participants, my n value. So I have 60 in my row. Okay, my critical value is 60. A man-written U is slightly different because it's an independent groups design. So in this, I would get 2 separate groups of participants, one's to exercise, one not, and then to rate themselves on positive regard. I could have more in one set of data than another. There could be more in condition A than condition B. So what I do then is I have this table here. Now let's break it down. First of all, it will tell you whether it's a one-tailed or two-tailed table. There's no need to select any rows or columns for that. The level of significance is 1%. Notice it's called alpha there. That's a more pure mathematical term for it. But if you notice the way the numbers are structured, if there's a point and then some numbers, you think, yes, actually, that will work for me. So I got 15 participants in both of my conditions. So the number of people in condition 1 is 15. The number of people in condition 2 is 15, N1, N2. I therefore have my column and my row, and so 36 is my critical value. So now we come to chi-squared. Now chi-squared is slightly different in that it uses nominal data in a way, and so they look at the number of options or the number of categories in that nominal data, so degrees of freedom. So just like the Man-Whitney U, you won't have to select any one-tailed or two-tailed because they are put into the tables for them, separate tables. But you will have to look for your level of significance. So here our level of significance, as you can see, 0.05. I work it out. It doesn't say level of significance on there, but I can see by the numbers, that's what it is, 0.05. Now my degrees of freedom, because I'm going to get my participants to look at 6 different forms of exercise and 6 different aspects of happiness. I'm like, right, okay, I've got five categories that can be different, and if they don't choose any of the ones, they have to have number 6. So my degrees of freedom are 5. 5 things change. Once again, don't worry about that. They will tell you what the degrees of freedom are. All you need to do is find it on the table. So there's my column. There I have 11.07. Okay, that's my critical value. Now, you might be feeling like this lad here, but you can get there, don't worry. And once you start looking at the tables that we find, but you've identified your critical value. Now here's where it gets a little bit more fun, in that your different statistical tests, the observed value, some need to be higher and some need to be lower than your critical value. As you can see here, basically it's any test that finds a difference tends to be lower, and then the chi-squared and Spearman Road correlations higher. But don't forget, a chi-squared can test whether it is a difference or a relationship. So I have a very clever way, there's Mr. Clever down there, a way of remembering it. And there's 2 different ways of doing it. One way is that chi rhymes with high, yeah, high chi, so it has to be higher. And another one is that you need to throw a spear high. Yeah, if you're going to get that spear going, it needs to be thrown high. Okay, and so those help you remember, oh yes, it needs to be higher. Now another way, which one of my colleagues showed me, which is a great way of remembering it, is something slightly different, and it's this. Whoa, make a box, air box. Okay, what does that mean? Remember our lovely table with all of the different statistical tests on. Well, if you have an L, there you go, lower, okay, on that table, you hit all the ones that need lower. And then the ones that are higher look like this. Got that? Lower. Sign, Wilcox and Man-Whitney, lower. So in the exam, if you're there, doing this, that's fine, because what we know is you're choosing the right statistical test. Okay, so you now have an observed value. You've identified the critical value. You now know from the test that you're using whether it should be higher or lower. What that does is how the observed value relates to the critical value tells you whether you have a significant finding or not. Remember, our null hypothesis is saying that it's just happened by chance. What we're looking for is a significance. And so what we're saying is, right, our level of significance for this case is 0.05. We're saying, look, if our level of significance, if we're saying is if there's 5% chance or less, that's okay. Well, that's enough to say that that level, we're going to say this is significant. If it's above, then we're going to say it's just a chance finding. Okay, so if we therefore have a significant finding, we accept our experimental or our research hypotheses, and we reject the null. If it's not significant, then we have to reject our research hypotheses and accept the null. Okay, so remember, if you haven't got it, you're in the dumps because you've just, that's okay, that's good for science. It means that you've shown you're ruling something out. But if you do, it's like, brilliant, yes, I have here a significant finding, I can accept my research hypotheses. Okay, let's have a look at a practical that we did with my students. I had to rate 10 couples on attractiveness, and the idea is to find matching hypotheses, meaning a positive correlation. The more attractive one partner is, the more attractive the other one will. The idea that we form relationships with people of similar attractiveness. If you are interested in that, there is a practical, if you go onto QE Psychology channel and look at correlational research in psychology, matching hypotheses practical, you'll be able to have a go at this yourself. So I had a little go. I had a quick go, and my hypothesis is that there will be a significant positive correlation in the attractiveness, rated attractiveness between partners in romantic relationships, and that my null hypothesis that any correlation in the rated attractiveness will be due to chance. So what do? First of all, I choose my level of significance. If I think of my 5 steps, so I choose my level. This time I want 1%. So look, it needs to be 1% left to chance. Then I need to choose my statistical test. Well, I'm looking at correlation. It's rated attractiveness using ordinal data. I need a Spearman Road. So then I need to calculate my observed value. Now I've used this website down here to do it. Those are my ratings there, and I put them in at that website and press go on a Spearman Row, and woof, out they come. Now, as you can see, if I look up here, that is my observed value, RS equals. So, and we know as a correlation coefficient, it's positive, and I'm going to put it as 860. I'm going to round it up to just 3 points, and that's what we will do. That's the decimal point. And so, great, that's strong. That's a strong positive correlation. But is it significant? Is it significant? We'll find out. We'll find out once we've looked at it and compared to the critical value. So I'm doing a Spearman Row. I have a positive correlation, so it's one-tailed. I said 1% was my level of significance. Now this time I had, so if I find my column, this time I had 10 pictures. Remember I said N is the number of items of data. Now it's usually the number of participants, but this is actually the number of items. I had 10 couples, so it's 10 sets of data. Okay, so now my critical value is 0.649. Right, let's have a look then. Let's have a look. So there's my hypotheses. There's my hypotheses there. Which one's going to get it? Which one am I going to accept and which one is going to get rejected? Okay, so my observed value is 0.860. We said it was strong. My critical value is 0.649. It's a Spearman Row, so I know, remember high, got it higher, that my observed value has to be higher than my critical value, which it is. So therefore, the level of significance is P 0.01. If I'd got an observed value of 0.649, I would put P equals. But because it is less than, it's great, yeah, it's great. I could put my probability is less than 0.01, meaning there is less than 1% due to chance. I accept my research hypotheses and reject my null hypotheses. Now, what happens if I have an exam question? How do I write that? Just a bit of note. Often students to say accept or reject, well, they're going to get 1 mark out of 2 or 1 mark out of 3. You need to put all of the detail in. Remember, link and put the numbers in. So what have we got here? In my answer, the observed value, I put the number in. And I put the test that I was used. It's higher than, so I'm clearly saying it's higher than the critical value. I put the number in, yeah, 0.649. And I put the level of significance in, 0.01. Therefore, the probability that any correlation in the rated attractiveness between partners in romantic relationships are linked to the study is due to chance. And here's the big part. The research hypotheses can be accepted and the null hypothesis rejected. Yeah, we've got that written down. Okay, so I'm on. All right, what have we learned today? We've learned that a statistical test calculates an observed value and that the observed value is known by a letter and is different according to the statistical test that you are using. We have also learned that you have to take the observed value and compare it to a critical value to establish if it is significant, and that you obtain a critical value from a table. And in order to read the tables, you need to know whether you've got a directional or non-directional hypothesis, one-tailed or two-tailed test. You need to know what level of significance you're looking for, and you need to know how much data you've got, the n value or degrees of freedom. Remember, it will tell you the degrees of freedom if it asks for that. Then you compare your critical value to identify if it's significant. Now, in some of the tests, Spearman Road and chi-squared, the observed value needs to be higher than the critical value. For the others, it has to be lower. Once you've done that, you've established if it's significant or not, you can then use that to accept your research hypotheses and reject your null, or accept your null hypotheses and reject your, am I getting this right? You accept your null and reject your research hypotheses. Well done, you've got through it. Now, if you have any questions, don't forget, put them in the email your teacher, put them in the posts, have a look at that. But you may want to watch this film again or look through your booklets, but you can do it. That's well done.